Okay, so we're going to look at the CA because, as I said, I feel like this assignment is you need a little bit extra seeing. So we're going to start. They do say they're calculator active. You don't necessarily need a calculator for these, but you may use one. We're going to start with this one. But since this starts as a logarithm, you have to play the restrictions game. And a disclaimer, if you can write small and you can abbreviate this is just scrap work, but I'm writing big, so it's up to you. I would probably use a separate sheet of paper today, but you're not going to be forced into doing anything. So with restrictions here, we care about what's inside the logarithm, so we have to understand that x plus a has to be greater than 0. So we'll subtract 8 from both sides, and x would be greater than negative 8. So from a number line perspective, only answers that are greater than 8 will be allowed. So this particular problem, it's a logarithm, so the first thing we've got to do is get the log by itself before we do any exponentiation. So what we're going to do first is to add 6 on both sides. And we'll be left with log base 5 of x plus 8 is less than 2. Since the log is now by itself, we can do exponentiation to get rid of the log. So I'm going to exponentiate this side, exponentiate that side. Cancellation, x plus 8 is less than, and then 5 squared is 25. We got one more step in the equation. We're going to subtract 8 from both sides, and we're going to have x is less than 17. Since x is less than 17, that is kind of what our answer is, but that's not the actual answer. So you probably, I don't know, probably shouldn't abbreviate this if you take the AP exam, but for today, this is perfectly fine. So we had a restriction earlier that x was greater than negative 8, which from a number line perspective, negative 8 somewhere over here, and that would be the line going that direction. But the answer we got when we solved the problem was x is less than 17. So here's 17, and this is the piece that goes this way. But you have to find where they overlap, because if we use any number that is not greater than negative 8, it fails this scenario. If we use any number that's bigger than 17, it fails this scenario. So your answer is the interval where they overlap each other. So this is where it was different than the example problem. So your final answer for this would be x is between 17 and 8, negative 8, non-inclusive. Or you could write your answer as parentheses, negative 8 to 17. It's a lot of work to get there. So if you need a second to catch up on this, maybe ask the sub if they know. If you got any questions, that's fine. Or look again at the smartest person in the room and ask them if they understand what's going on. And if they say no, don't believe them. Anyway, we're going to move on to the next question on the CA. We'll just go ahead and look at all of them. So moving on to question 2, where this is 8 times 4 to the 2x power minus 5 is greater than negative 3. So here's the nice thing about this problem. It starts out as an exponential. We don't worry about restrictions. We just have to solve the problem. So we need to get this 4 with that power by itself. So the first step we got to do is we got to either get rid of the 5 or the 8. We'll get rid of the 5. Add 5 to both sides. We'll have 8 times 4 to the 2x power is greater than 2. Ooh, now this is going to get interesting. We've got to divide both sides by 8. we'll have 4 to the 2x power, but 2/8 reduces to 1/4. So we don't exponentiate to get rid of this, we do the log of both sides. So I'm going to do a log with a base of 4 to the 2x on this side is greater than a log base 4 of 1/4. Now that looks horrible because I actually, I made a mistake. I always make mistakes. This side cancels. We're left with 2x. Now 4 to the, so, this is kind of, I'm going to do D&W scratch, even in a video. If 4 to the 1 is equal to 4, then 4 to what power would be 1/4? And just a reminder, if it's a negative exponent, it would go on the bottom. So 4 to what power would get you to the 1/4? Well, that would be -1. The final step to this problem is to divide both sides by 2. And we'll have x is greater than -1/2. Since there's no restrictions on exponentials, we don't have to do any of the extra thinking. This is their answer, or you could write it as from -1/2 to infinity. So there's example 2 of the CA. And then now let's look at a third type of problem on the CA. Problem 3. Log of 3x minus 2 is greater than or equal to the log of 5 plus the log of x minus 4. We got a lot of logs going on in this problem. So the unfortunate side of things is we got to figure out the restrictions again, and we're going to set up 2 inequalities. We don't have to worry about that one because there's no x, but we have to know that 3x minus 2 has to be greater than 0, and we also need to know that x minus 4 has to be greater than 0. So anything that's logged, you got to look for the restrictions. This would end up being 3x is greater than 2. Divide both sides by 3, x would be greater than 2/3. Now I'm just going to go ahead and kind of start a number line here. Say if I had 2/3, that would be that piece of the restriction. On this one we'll have x is greater than 4. So 4 would be out here somewhere. And I'm just going to make that a little longer just to emphasize. We're looking at where they overlap, which would be this interval. So the actual restriction would be x is greater than 4, because that's where the 2 overlap. So that's all that work before we even start the problem. So now it's time to start the problem. We're going to have to combine logs. So we're going to have log of 3x minus 2 is greater than or equal to the log of 5x minus 4. Since it's an addition, they combine as a times. And since this problem has a log on the left side and right side, we can use the one-to-one property to make sure they just go away. And we're going to be left with 3x minus 2 is greater than or equal to 5x minus 20. Going to distribute the 5. That's how I got to the 20. And then we solve it just like any inequality. Subtract 3x, subtract 3x. -2 is greater than or equal to 2x minus 20. Add 20 to both sides. 18 is greater than or equal to x. And once again, just because I'm the old school fanatic, I do like moving the x to the left side. So this answer is x is less than or equal to, just kidding. Mr. Taylor and his mistakes. I forgot to bring the 2x down. I am not redoing this video. I need to divide by 2. So ignore this smudge. People who are just looking at the notes go, I wonder what that smudge is. It's a mistake. We get 9 is greater than or equal to x. Now, going back to what I said earlier, I like having the x on the left side, so if I'm looking at my answer, I'm going to make it x is less than or equal to 9. So just kind of going back to what we did earlier, we have a restriction that we had earlier, which x has to be greater than 4 for the restriction. So on a number line, it would look more like this. But for the answer we got when we actually solved the inequality, we got x is less than or equal to 9, which would be out here somewhere. This is the first problem we have talked about with an equals to with it as well. So it's really a solid here at the 9, and it would go this way. So where do they overlap? Well, they overlap in the middle. And the reason why is if the answer is not bigger than 4, then it would fail the restrictions of the logs. If the answer is bigger than 9, then it fails that part of the answer. So we look at where they overlap. So your answer would really be x is less than or equal to 9, but also no equals to for this piece of 4. Or you could write your answer as 4 to 9, but making sure you use a parentheses on the 4 and a bracket on the 9. So, okie dokie. Let's go to number 4. Number 4. Log with a base of 3 of 2x minus 3 is greater than or equal to 3. Okie dokie. We started out with a log. So let's start talking about our restrictions a little bit. So I will set up 2x minus 3 is greater than 0. Adding 3 to both sides, we'll get 2x is greater than 3. And then we'll divide both sides by 2, and we'll get x is greater than 3 over 2. You may read that as x is greater than 1.5 or 1.5. Anyway, I'm keeping it 3 over 2. So the restriction that we got is if we have 3 over 2 on a number line, it's going to go in this direction. So let's solve this problem like normal. This is actually probably easier than the previous examples because this is already by itself on the side. So to get rid of that 3, we do the exponentiation rule. We're going to exponentiate by 3 on both sides. That will make this piece cancel. We're left with 2x minus 3. And 3 to the third power, it goes from 3 to 9 to 27. So, see, we've not needed a calculator for this part of the CA. But on the practice, do what you need to do. Some of the problems are going to have such weird numbers. I'm fine with a calculator today or Desmos, unless they take Desmos away in the future. Anyway, I'm going to shut up. Let's move on. We'll add 3 to both sides. 2x is greater than or equal to 30. Divide both sides by 2. And then we get the answer of the inequality is greater than or equal to 15. So once again, we got to talk about restrictions. We had earlier x is greater than 3 halves. So on a number line, 3 halves may be here and it goes this way. But then you get this answer, which is x is greater than or equal to 15, which 15 would be out here somewhere. Filling it in because of the equals and going in this direction. Where do they overlap? In this territory. So your final answer would be x is greater than or equal to 15, or, since we're used to writing this in interval notation, 15 to infinity, bracket on the 15, parentheses with the infinity. So yep, we're going to go ahead and find the inverses as well since we're here. So this, we'll go ahead and finish the rest of the CA. So for question number 5, we're going to start off with g of x is equal to log of 2x minus 3 minus 5. At least you don't have to deal with restrictions on inverses. So going old school, this turns into y is equal to log of 2x minus 3 minus 5. And then at this point, we are going to do the switch. So we'll have x is equal to the log of 2y minus 3 minus 5. So before we try to, our whole goal, get that y by itself. So if we want to get that y by itself, we need to get rid of this 5 first. So we're going to add 5 to both sides. So x plus 5 is equal to log of 2y minus 3. Now the log is by itself, and since there's a hidden base of 10 on the bottom of that log, we're going to exponentiate both sides by the number 10 to get the y out of the log. So this would end up being 2y minus 3 is equal to 10 to the x plus 5 power. Couple more steps. Add 3 to both sides. So we'll have 10 to the x plus 5 power plus 3 is equal to 2y. And then we'll divide both sides by 2. Don't worry about trying to make anything super nice. We'll have y is equal to 10 to the x plus 5 plus 3 over 2. And if you know at this point you could have skipped to the pretty part, we're going to go ahead and write our final answer. G negative 1 of x is equal to 10 to the x plus 5 power plus 3 over 2, and we are done. That is the inverse. If you really feel like checking it, you can graph them both in Desmos and see if they cross over y equals x. So last problem. Hopefully you guys are still awake. Number 6. We're going to look at f of x is equal to 2 to the 3x plus 1 plus 10. So here we go. Going to switch this to y. We're going to have 2 to the 3x plus 1 plus 10. If you can't see, please move closer. So we'll do what we call the switch, where x has become y. So we'll have x is equal to 2 to the 3 y plus 1 plus 10. So before we can do anything to get rid of the 3 and the y, we got to get rid of the 2 and the 10. So the next step, we're going to subtract 10 from both sides. So we'll have x minus 10 is equal to 2 times 3 to the y plus 1. And then now we're going to take both sides and divide it by 2. We will end up with 3 to the y plus 1. And then you'll have x minus 10 over 2. So since this is an exponential, we're going to do logs to get rid of it. So we will take the log of base 3 of 3 to the y plus 1 on this side. But we'll also then do log base 3 of this side, because then those will cancel each other out. We will be left with y plus 1. And then on the other side, you have log base 3 of x minus 10 over 2. And then we got one more step to get the y by itself. Subtract 1. So we will have log base 3 of x minus 10 over 2 minus 1 is equal to y. and then we clean it up. Since the y is by itself, we're going to write out our final answer. F negative 1 of x is equal to log base 3 of x minus 10 over 2 minus 1. If there are any questions, feel free to email me. I will get back with you as soon as I can. Anyway, have a good afternoon. Hope this doesn't ruin your afternoon.